Okay, we're starting with lesson 5.2, exponential functions. Going off with the basic definition of what an exponential function is. Go off to the full screen here. And exponential function, as you might expect, is a function that has some number of base. This a here represents the base raised to some power, which we represent with the variable x. So in this case, we're talking about all the values of a is greater than 0. So this base is greater than 0 and it's not equal to 0, then this is an exponential function with a base of a. So these are things like 5 to the x power, something like that. Y equals 5 to the x, exponential function. And down here at the bottom we have additional properties of exponents which you may have forgotten, or it's good to review. A of x is a real number, is a unique real number. And if they have the same base, a and a are the base, and the exponents, and they're equal to each other, then that means that the exponents also have to be each other. We're going to have some problems probably tomorrow where we figure out that what those exponents are by using this property. The other thing is when a is greater than 1. So this is a is 1 or more. And then we're talking about the exponents here, m and n. M is less than n, is the way that reads. Then the values are going to be less than each other. And they give an example over here, 4 to the second power is less than 4 to the third power, which makes sense. But the other thing that sometimes doesn't make sense, if a is between 0 and 1, right? A is a fraction, a decimal number between 0 and 1. Then the same exponents, m less than n, we get the opposite effect, right? The exponent, the base raised to a smaller exponent is going to be greater than a fraction raised to a higher exponent. And they show this over here with 1/2 squared is greater than 1/2 to the third power. This is going to be 1/4 is greater than 1/8. Okay, so just some basic little review of what we're talking about here on exponential functions. We're going to talk about the graphs of exponential functions mostly in this lesson, and they have the graph here, example graph of f of x equals 2 to the x power. So they want you to graph that and determine the domain and range of f's. They have a nice little graph here in blue, and they show a table over here of the different values for have an x and y table, different values of x, give me different values of y. So what's the domain and range of this function? Just looking at it, it looks like the upper end of the range is going off to infinity, right? It looks that's pretty good. But down here, is this going to 0 or is it not? Is it an asymptote? I can't really tell from this graph. So the solution is down here. It is an asymptote. There is 0 is the asymptote. There's no x-intercept. It never crosses that y equals the x-axis. And any number to the 0 power is 1. So the y-intercept is always here at 1. Right? When x is 0, y is going to be 1. It doesn't matter what the base is on it. Anything raised to the 0 power is always 1. And the domain is negative to positive infinity, and the range doesn't include 0, and it goes up to infinity. So it has that, it never crosses the x-axis. It never gets to 0. That's an asymptote there at y equals x equals 0, or y equals 0, sorry. Okay, so here's some function capsule, some facts about these functions when we have the base greater than 1. So we're talking about the base greater than 1 on here. The domain is positive, negative to positive infinity, and the range is 0 to infinity. Okay, it looks like this in the blue here is how the graph looks, and I want you to make note of these 3 points. This point, this point, and this point, because we're going to graph these functions here in a minute, and I want you to always graph at least these 3 points on the graph and maybe a couple more on either side of those. So 3 to 5 points is a good thing to start on graphing these when you graph these exponential functions. It's increasing, always increasing, and continuous on its entire domain. So there's no from negative infinity up to infinity. It's always increasing. It's getting bigger. The x-axis is the horizontal asymptote. And this, as x, it goes to this as x goes to negative infinity, it gets closer to that asymptote, but never quite hits it. The graph always goes through these 3 points, -1, and this is a to the -1 power. So if x is -1, if we had, like we had on the last one, y equals 2 to the x, and x was -1, y would equal 2 to the -1 power, and that's just equal to, remember we have a -1, we put it 1 over 2, it's just going to be 1/2. So it's going to be whatever, this point is always going to be whatever a is over 1. This point is always going to be the same no matter what the base is. And this base, if we raise something to it, the first power, we always get the base as the answer. So y equals 2 to the first power always equals 2. So if we had a function from this function 2x. Okay, so graph the function y equals 2x and determine the domain and the range of f. Okay, so to graph that, we want to graph the first point on our, I want to get some x's and y's on our graph. And we know that one of the points is always going to be when x is 0, y is 1. So I'll put that there, x is 0, y is 1. I always know that's going to be a point. And if x is 1, y is going to be whatever our base is. And our base in this case is 2. So y is 1, x is 2 is there like that. And I may just make another point on the other side of that. If x is 2, we get 2 to the second power, which is 4. I put that over here on this side. Okay, so what about going the other way when it's -1? And we had that on the other graph, on the other part of here, when it's equal to -1, it's just 1 over whatever the base is, right? 1 over whatever the base is. So our base is 2, so it's just going to be 1/2. The values of y are never going to be negative. Even if x is negative, the values for this are always going to be positive unless we have some kind of offset or something. So 1 equals 1/2 there. And I could maybe do a -2, and I'd get 1/4. Should be down like that. So connect the dots. Put little arrows at the end. This doesn't touch 2 quite yet, so that's good. Okay, so that's what my graph should look like. I want you to graph these 3 points all the time. This point, 1, and whatever, a -1. At least graph those 3 points when you're doing the graph, and maybe one more on each side, -2. So these 5 points are what you should graph when you ask the graph by hand. And we're going to talk about the other side of this, the other part of this range where a is between 0 and 1. So in this part, is we have a is the negative, and the graph looks like this. It slopes down the other way, right? Instead of as x gets bigger, the value of y gets smaller. And you had just the opposite effect last time. Okay, so it's decreasing and continues on its entire domain. The domain and range are the same as they were on the other function. It still never gets negative. Domain is defined from -infinity to infinity, and the range is 0 to infinity. So it looks like that. And the x-axis again is a horizontal asymptote, and we have these same 3 points, right? But now that it's a fraction, it works a little differently. So the 0 the 0, 1 is still in the same place, right? But then when we have a function like y equals 1/2 to the x, every time we have a negative value of x, it's going to like flip the fraction, right? So I'll just do it for, and I'll just continue with this one, I guess. If x is -1, like it says on this point here, so y equals 1/2 to the -1 power. So that equals 1 over 1/2, right? When you have a fraction underneath like that, this is 1 divided by 1/2. 1 divided by 1/2 is what that is. Remember the little trick we did with dividing by fractions is we multiplied by the inverse. So this equals 1 times 2, which equals 2. So this point is always going to be the inverse of whatever the base is. If the base is 1/2, we're going to flip that over, and this point would be 2. And this would always be whatever the base is. This point, when x equals 1, of course, it's just whatever the base is and that. So you can see when x are negative, it gives higher values because we're dividing by a fraction. If we divide by a smaller and smaller fraction, we get a bigger and bigger number. Okay, so graph this one, the same kind of process, x and y. So I graph the x is 0, y is 1. Always start with that one first. Go on either side of that. 1. For this one, I'm going to get 1/2 when it's 1. And when it's -1, I'm going to get 2, right? I flip the fraction over. It's not going to be negative, remember. It's going to be 2. And when it's -2, x to the -2 is going to be 1/4, -1/4, and that's going to be 4. So it goes up over here like that. And for 2, it's going to be 1/2 squared, which is going to be 1/4. So you can see that it's going to keep getting smaller and smaller as we go down to here to this asymptote that is the x-axis, and it's going to go up to infinity this way and never quite get to 0 on the other side. Okay, so we can translate these graphs also, the exponential graphs. Y equals -2x plus 3. So what happens here? Explain how the graph is obtained from the basic graph of y equals 2x. Okay, so just looking at it, what happens with the negative part here? What does that do to it? That flips it which way? Which way does it flip it? I'll let you think about that for a second. The plus 3, what does that do? That jumps the graph up 3 places each time. Okay, so this negative is a reflection across the x-axis. So instead of, normally we would have the graph going this kind of, the graph would be looking like, be increasing, going up like that. Right, that's what it normally look like. But if we do this negative sign, flips it over. So it's now going, instead of going like that, it's flipped over where everything was positive, now it's negative, and so it looks like that. The bigger positive numbers are now the bigger negative numbers. And the plus 3 makes it translated 3 units up, so it puts my asymptote up at y equals 3. So it looks like this. This is the calculator version of it. So it's pretty simple, a little translation there. They just flipped it over and raised it up 3. Okay, so graph each function. So negative x, 2x squared. So how do we graph that? So we need to graph our 3 basic points, right? Our x and our y. We're going to start with 0, 1 because they always go through, x is 0, it always goes through 1. But now what happens when it's negative is going to be -1, right? Because that negative changes the value. So it's going to go 0, -1, And for my x equals 1, normally I would get 2, right? But since it's negative, I'm going to get negative 2. So x equals 1, I get negative 2. X equals 2, I'd normally get 4, now I'm going to get negative 4. At negative 1, normally I'd get 1/2, now I'm going to get negative 1/2. And negative 2, I get negative 1/4. Okay, so that's my graph here. I'll sketch that in. I think the smartboard can do this, can graph it for me if I get it over here right. Did it do it? Why didn't it do it? There we go. Got it. So pretty close to what the function should have been. My lines were, a little off, but not too bad. Just because I drew them wrong. I don't know what happened here. 1, 2, 2. Oh, because I can't count. That's why. This is, I put it at 3 instead of 4. Okay. Well, if I could count, that would be a better way to do the graph. Okay, same thing on this one. So what happens on this one when we have the x plus 3? What does that do to our graph? And so what happens when we have a regular graph of y equals x plus 3? What happens there when we do that graph? Well, which way is it shifted? Is it shifted? It's going to be a horizontal shift, right? Which way does it go? It goes the opposite way of what you think. So this would be a shift over to the left 3 places. Okay, so let's take our little table and always start off with x equals 0. But now with 0, what would I get? If I put 0 plus 3 here, I would get 3. But I don't want it to be 3. I want it to be 0. So I'm going to start off with negative 3. Negative 3 gives me an exponent of 0, which makes that 1. So at negative 3, I'm going to have the value be 1. Okay, so negative 3 is 1. Then I'm going to pick my points just like I would. So negative 2 would give me an exponent of 1. So 2 to the first power is 1. So negative 2 would be 2. And negative 1 would give me a power of positive 2, which would make that 4. So negative 1 would be up here at 4, like that. And if I go the other way, negative 4 would give me an exponent of negative 1, which would be 1/2. And negative 5 would give me an exponent of negative 2, which would be 1/4, down like that. Okay, so let me get the smartboard to graph it for me. Okay, so it did better on that one. Pretty good. Okay, so this function, we're going to do the same thing. So this one is what's happened here. There's nothing to the 2x. Then what are we going to do with the plus 3? We're going to move it up 3. So this translation is going to look like this when we graph our x and our y. X is 0. Y would normally be anything to the 0 power is 1, but 1 plus 3 gives me 4. So at 0, I'm going to start up here at 4. At 1, normally it'd be 2. 2 plus 3 is 5, so now it's 5. At 2, normally it'd be 4 plus 3 would be all the way up at 7. Okay, so negative 1. So negative 1, what does that give us? That gives us, normally that gives us 1/2, right? So 1/2 plus 3 is 3.5. And -2 gives me 1/4, but 3 1/4 like that. So we're going to get a horizontal asymptote is going to be here at +3. It's just going to be moved up. And our graph is going to go up like that. And the horizontal asymptote, instead of being down here at 0, it's going to be at 3. Let the smartboard, oops, missed it. Smartboard graph it for me. Okay, so my purple line, pretty good on there, graph like that. Okay, so that's the end of the video lesson. So fill out the form. Be sure to put your questions down about the video, and we'll talk about it tomorrow in class.